Hello everyone, my name is Alvaro, and in this video I will be solving one of the problems in the blind Leetcode 75 problem list. Today I will be solving problem 206, which is reverse a linked list. This is one of the most commonly asked questions on Leetcode, mostly for internships. I wouldn't say this is a problem that you will encounter a lot of times, especially when applying to full-time jobs. But nonetheless, it's a good problem to know how to solve because it lays down the very basics on how to manipulate graphs and how to traverse them, as linked lists are a type of graph that's very commonly used in interviews. So, the problem statement is the following. Given the head of a singly linked list, reverse the list and return the reverse list. As we can see here, we're given the node. It's called head. So what we're given is an actual node, not the linked list itself. We're given a pointer towards the head, then it goes to node 2, 3, 4, 5, and then we return the reverse list. Here we can see the same thing, and if the input is none, then we will return none. So that's an edge case that we can get rid of already. So if the head is none, then we can just return none. And that way the program doesn't have to run anymore. Now what's going to help us understand how to do this problem is if we picture this image a little bit differently. So instead of thinking about the reverse list as this diagram, think about it as this diagram, but with the arrows pointing to the opposite direction, and the node that we will return is this one right here, node number 5. At the end of the day, it's the same thing, but it might help you a little bit more if you've never done this type of problem before. So how are we going to reverse the list? So in this case, we're going to use pointers. Pointers are simply a variable that, like the name says, they point towards a place in memory. In this case, we will use 2 pointers that point to different nodes. Nodes being these little circles in the diagram. Head is the node that points towards the first element in the list. So, what do we have here? How are we going to reverse the list? The basic idea is that we're going to use 2 pointers. We can name them, let's just say, previous and current. And we can say, while current is not none, we will do the following. So right now, previous is here, and then current is pointing towards the 1. So the basic idea here is that we can create a temporary pointer that points towards the 2. And what is 2 in reference to the current element? As we can see, there is a .next value on each node. So this node right here is equal to current.next. So we can call it next node is equal to current.next. And now we have a pointer pointing towards this. What we can say now is, okay, we can say current.next is equal to previous, because like I said, we want to reverse the arrows. Is equal to the previous node. Now there will be this arrow right here will point towards nothing, like in this diagram, right? There's nothing pointing after the 1. So current.next is equal to previous. And what we will do is now we will make previous equal to the current node, and the current node, we make it equal to the next node that we created. So what's going to happen now? So suppose that now previous is equal to 1 and current is equal to 2. So what's going to happen now is that we create the next node. So next node is going to point towards 3. Current.next, in this case, this arrow right here, will point towards the 1. So now there will be an arrow pointing from the 2 towards the 1. And then previous will be 2, current will be 3. And then we keep repeating these. We keep repeating this loop until current is equal to none. When current is equal to none, since previous is always before current, we know that previous will be pointing towards this node right here. And at this point, every single arrow should be flipped in direction in the diagram. So what we will do is simply return the node previous. This is also like a little bit, as you can see, there's a difference in runtime, and you will probably see that in the videos. Like there's some variance here, 39 milliseconds versus 17. But basically, this is the most efficient solution, the most efficient iterative solution. And I believe it's also the most efficient because I think the iterative is slightly faster than the recursive solution. But this is a O of n. This solution uses has a runtime of O of n because we will traverse the list just once and we will visit each element once. And each operation that we do takes O of 1 time. The operations being just switching pointers and also changing each pointer. So for example, what I mean by switching pointer is like flipping the arrow and then moving previous to the next one and current to the next one and so on and so on. Yeah, and then it takes O of 1 space because we're not storing the nodes anywhere. We're simply manipulating them the way they are. And yeah, that's basically it. I hope you enjoyed the video and the problem, and I hope to see you on the next video. Bye-bye.